Afternoon, everyone. Today is Christmas Eve, and you know what that means? Time to grind some LeetCode. Absolutely, it is Christmas Eve special LeetCode grinding edition. Let's go! All right. Okay, so we're gonna randomize it, and we're gonna pick a medium. Let's go. Let's go. Let's go. Ready? 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 Here we go. Okay. Closest medium is this one. Battleships in a board. All right, let's go. Battleships and a board, 419. Battleships and a board. Given an M by N matrix board where each cell is a battleship, X, or empty, which is a dot, return the number of battleships on board. Okay. Battleships can be placed horizontally or vertically on a board. In other words, they can only be made in the shape 1 by k, 1 row, k columns, or k by 1, k rows, 1 column, where k can be any size. Okay, so I think that means that they can just be like horizontally in a line or vertically in a line. Kind of what we're seeing here, like vertically but in a line. It's not like here, here, then here, then here, then here, then here, then here, something strange configuration like that. They have to be lined up either horizontally or vertically. Um, where K can be any size, at least one horizontal or vertical cell separates between two battleships. There are no adjacent battleships. Okay. So we have here, and the output is 2. Oh, wait, so hold on. We are trying to find battleships on a board where each cell is a battleship. So does this mean that there are 3 battleships, like, together? Or does this mean that, like, this entire thing is one battleship, and then this is also a battleship? Okay, so we have this, and the output is 2. I think that means that each like horizontal or vertical like grouping is one ship. Okay. So then we're just okay, whatever. This is just constraints telling us that we have one or more M and over 200n, which what was that even defined as? Oh, that's just like the matrix. Anyways, let's just start. Okay, so what do we want to do? So the first thing that immediately comes, which is like, okay, cool. Well, let's just iterate through every cell. Okay, but that's not quite going to work because let's say that there was let's see. Let's say that there was a cell, like a battleship here and here. Okay. And then if I come here, I see a ship. Alright. This ship, I'm going to add 1. Okay, then I come here. Nothing, nothing. Okay, here's a ship. I see 2. Then I come here. Oh, I see a ship. Now there's 3. No. No. So this is part of this grouping, this ship. Again, imagine that there is an X here and an X here. So what I'm thinking about doing is kind of like this. So I'm going to have a visited section. And this visited section is going to contain those elements that have already been found to be part of a ship. Okay, and the way that I'm going to do this is I'm going to go through the grid and I'm going to pass in each of these elements like this. And each time I pass in an element, if I find a ship, I'm going to do a depth first search either horizontally or vertically. And now I'm gonna look back at the problem statement because I want to see, do I have to keep track of the information like, oh, okay, it's horizontal, so therefore I have to continue to go horizontal, this way, or it's vertical, so I have to go vertical, or is it something that I can just do, oh, I'm going to try horizontal and I'm going to try vertical. And the reason that I might be able to do that was because I vaguely recall or vaguely remember when I was just reading it now something about not no hor or like nothing is connected. No two groups, I mean, are connected. Okay, so battleships can be placed horizontally or vertically on a board. Cool. In other words, they can only be made of a shape of. Okay, so yeah, like this is one battleship, and it is in the shape of 1 by k, or k by 1 for rows and columns, where k can be any size. So this could actually be really large, right? But that wouldn't matter because I would start here. Okay, cool. So come here, and then there's, let's say that there's like 10,000 below here, right? Well, I would just start right here, and I'd do my depth first search, and I would come here, then come here, then come here, then come here, and then I would, each time I do a depth first search and I find an element which is part of that ship, I put it into that visited, and then when I come back around here, oh, this is already in visited, I'm not going to pay attention to it. Okay, so now, where k can be any size, at least one horizontal or vertical cell separates two battleships. So at least one horizontal or vertical cell. Okay, so yeah, that means that it won't be touching. So for example, if I have uh let's see, an XXX right here, then this would be a dot, because we can't have, if there was an X here, there would be not a vertical or a horizontal gap between this group and this group, or this battleship and this battleship. Okay, so I can just apply a depth first search once I find something. So let's see. So visited equals set. So an empty set. Number of ships equals 0. So initially we don't have any ships. Then let's see. So I need to do so def traverse, and then I'm gonna take in like the XY coordinates, right? So row, column, okay. And then I now want to iterate through each of those lines, each of these columns and rows. So I am going to do a traverse on every single grid point within this larger grid point. If I find a ship, I'm going to then I'm going to iterate through each of these grid points. If I find a ship, I'm going to send that up. If I find a ship and it is not invisited, then I am going to send that up to the traverse function, and I'm going to do a depth first search. I'm going to find all of the X's which are part of this ship. I'm going to put that into visited, okay? Then I'm going to kick back to my iteration, and then I'm going to go and keep visiting the other ones. And let's just say that there was an X here and an X here, so I'm going to start. Bam, I found a ship. Okay, cool. Let's do this depth first search. So we start here, then go here, then go here. All three of these are now added to my visited set. So then I pop back up, and then I come here. Okay, from here, no ship. So I just go to the next column. No ship. I go to the next column. Ship. Okay, cool. So now I do a depth first search. Come up. All of these are now in visited. Then I pop over to this this grid point, but it's already in visited, so I don't do anything. Come here. Not a ship. Not a ship. Already in visited. Already in visited. Not a ship. Not a ship. Not a ship. Return, and at that point we had done 2 of the ships, so I just return that number. So that's how I'm gonna be going about this. So here we go. So for I in range, and then rows equals calls equals, and then let's see, if not board, return 0. So if there is no board, then we just return 0 because there's no ships on the board. So now this statement blocks the case where we don't have a board, so I can always do something like this. So length of board indexed at the 0th, because if I want to know how many columns there are, right, I need to index this 0th row. Here's the 0th row, so see the length of this 0th row. If I don't have a board, I'm going to try to index something that doesn't exist. I'm going to get an error. Length, and then this one is just length of board. So that's how many rows are in here. Okay, cool. So, rows for j in range calls. Okay, so now what do I want to do? If, and I'm going to make it a tuple, I, j, not in visited, and board, I, j, equals, and then it was, Battleship was denoted by an X. So what I'm doing here is if I have not added this, again, if this is an X and this is an X, if I come across something which is an X and I have not seen this, I have not already classified this X point as a battleship, it's not in visited, then I'm going to do a depth first search. I'm going to say, okay, I found one. I found a ship. This is a new ship. I haven't found it before. I'm going to increment the number of ships by 1. Then I'm going to find all of those elements which are part of this ship, add that to my visited, and then I'm just going to continue my search. So, number of ships plus equals 1. It's the same name. Okay, cool. No spelling errors. Then I am going to do a traverse of I and j, where I is the row, j is the column. Okay, and I'm going to pass that into here. Then this function is going to do a depth first search and add each of those elements that it finds to visited. Okay. So now, otherwise, if I come across an element that is in visited, I just want to go to the next one. So, okay, cool. If I see one that is a dot, I just want to go to the next one. So all I need to do now is actually implement this traverse function. So let's do that. First off, I want to process the specific grid point which I'm at. So visited.add and then row column. Okay. Then what do I want to do? So I can check. I actually only need to go horizontally and down. So I only need to go, I don't need to go left, and I don't need to try to go up. And the reason why I think I'm allowed to do this is because I'm starting at 0 0, right? I'm starting at 0, 0. So what are the rules in which I am adhering to? Well, if I'm here, there can't be a ship above here because that's out of the grid, right? So I can go down or I could go right, correct? And then I come here, and what are the possibilities of this cell? Well, there could be a ship here, or there could be a ship here, right? But there can't be a ship here because we just checked that. Does that make sense? So I don't need to actually traverse left or up. That's what I'm thinking. So let's okay, so column and then I actually do want to do some blocking where we are not going to we're gonna want to hit our base cases. So I'm gonna just make sure that we don't come off the grid here and we don't come off the grid here. So if row is larger than or equal to rows, or calls is greater than or equal to, this is just call, is greater than or equal to calls, then we just want to return. So if we are traversing towards the right, once we get to the case where it's bigger, again, we don't need to worry about the 0 because we're not going to be traversing left ways, but we are going to be traversing right ways. So once we get to this element here outside the bounds, that is the case where the where the column is equal to the calls, right? And in that case, we just want to return. We want to get out of there. Stop. Don't try to index anything. Don't try to do any funny business like that. Okay. This one, I mean, we technically could move it down here, but it doesn't really hurt or help. I mean, it's whatever. Like, we're essentially just adding a false value into visited, but that doesn't, we're not utilizing this visited to actually keep track of anything useful in terms of returning our answer. We're just using visited to say, like, okay, well, don't keep traversing, or we already kind of searched this, but we're doing that for a out of bounds. So it doesn't quite make sense. It won't hurt it, but it, okay, whatever. We can just put it below. It doesn't matter. There we go. Okay. Anyways. Okay, cool. So now what do we want to do? We want to traverse to the left and traverse to the right. So traverse and then row plus 1. So traverse and then row column plus 1. So this is going to be column. Now, what is the rule in which we are traversing? We want to find if that we only want to traverse if it is actually an X here, right? We don't want to traverse, like in this case here, there's an X and then a dot and a dot. So we don't want to traverse down because this lower element is a dot. We just want to return. We just want to say, okay, we're not traversing down anymore. Well, what about vertically? Okay, let's check vertically. Oh, there's a dot here. Don't do the horizontal either. So we need to add some blocking in here. So let's see. So if board, and then let's see, row plus 1 and column. And this will cause an error, but we're gonna fix that. Okay, so column, if that equals to x, then we want to traverse in that direction. Else, elif, there we go. Okay, so else, if the horizontal direction is equal to x, okay, then we want to traverse in the horizontal direction. Now, we have a problem though. So I'm indexing, I already guaranteed that this grid point, which we are on, exists. But I did not guarantee that the grid point next to it exists. So right here, I'm noticing that I'm indexing row plus 1. So I'm going to look at this one, column plus 1. I'm here. This cell exists. Cool. I'm not getting blocked by this case right here. I am going to get blocked by column plus 1. That's going to say outside the bounds of the array. It's going to crash. It's going to be bad news for everyone. So we need to add more blocking to make sure that we don't hit that check if column or row is out of the bounds of the array. All right, so if what? If row equals rows I'm thinking about maybe possibly doing this a slightly different way, actually. So I'll just do it this way. Rows minus 1 and here does so not equal rows minus 1. Okay. Column does not equal calls minus 1 and okay, so what I'm trying to do right now is in the case that this rows, which is columns is just kind of easier to explain. So column, that's right here defined as the length of the first index of the board. So that's this row right here. So it's the number of elements. So there's 1 element, 2 elements, 3 elements, 4 elements. 4 elements. Now, indexing and elements are different. So columns is the number of elements. There's 4 elements here. Columns is the index, and remember, index it starts at 0. So I want to look when I'm here, what index am I at? I'm at 0, 1, 2, 3. Okay, I'm at the 3rd index. So calls is going to equal 3. And now rows is going to equal 4. And when I'm in this case, I want to say, actually don't really check the left one or the right one. Don't really check it because you're going to go out of bounds. But if we're at the case where we're here at the 2 index and there's 4 elements, that's fine. We can check over here. That's fine. But if we're here, we're at the 3rd index and we're at the 4th and there's 4 elements. Okay, that's the problem. So that's why I say row, it does not equal rows minus 1. then and once that is, if that's true, then I can try to index this because it's going to be within the bounds of the array. If this is, if it is the case that rows is equal to rows minus 1, well then this statement here is going to fail. This statement here is going to fail, and we're not even going to check this second case after the and statement. So that's why we are not going to get an error, because we're not going to get that indexing. Okay, so then we're safe to traverse. Okay, so I think that is okay. So then we just return, should we try it? Should we try this? Let's see. Let's see what's up. An error. That's what's up. Okay. So set.add takes exactly one argument. Oh, because I need to do it as a tuple. I'm going to be adding these as a tuple. And then, yeah, because I put this not in visited. Cool. So let's try it. And there we go. Awesome, awesome, awesome. Wow. That actually was pretty smooth. I think that this is the smoothest problem that I've done since I started making these YouTube videos. Maybe I am improving. I don't want to get too confident. Hold on. I don't want to get too confident. But this one was fun. I liked this one. Okay. All right. Anyways, thank you guys so much for watching this video. If the video helped you, I would love if you subscribed. That would be awesome. And yeah, I'm gonna be back tomorrow. Christmas LeetCoding. Come on. Awesome. Time to go. Let's go. So yeah, subscribe. That would make my day. Anyways, yeah, I will see you guys tomorrow on Christmas, and we're gonna have an awesome LeetCoding time as well. Anyways, have a wonderful day. My name is Timothy Lee Grant, and I will see you tomorrow. All right. So yeah, have a wonderful Christmas, everyone.